Today we'll start in 4.3 distinguishing among atoms, atomic number and mass number. So let's look at this periodic table we have here. Or if you see this symbol, and we have a two different number. We have a large number and we have a small number. So what this number refer to? Mass and atomic and isotope. Mass number and atomic number. Always the large number represent a mass number, and I will tell you why in this slide. And the atomic number is always the smallest number and is represent the number of proton inside the nucleus, but the atomic number is the number of proton, and the mass number is the number of proton and neutron inside the nucleus. So if the mass number have the number of proton and neutron, and the atomic number has number just only the number of proton, that means the mass number is the atomic number plus the number of neutrons. That's why the atomic number always less than the mass number. If you want me to write that down, okay. So the mass number, this is a mass number, and the mass number is then an atomic number, which is a number of a proton, or the number of a proton, and we write here a positive charge for proton, plus the number of a neutron, and with this zero charge here because it's just a neutral. Okay, so we have this large number and we have this small number. So the small number represent always the atomic number, and the large number represent the mass number, and that the difference between atomic and mass number. So let's go to the second slide here, not this one. Okay, atomic number. So what make different elements different? So what make elements different from each other? How we can know that we have a different type of elements? If we have a different number of proton and number of electron, that means we have a different elements. So, or if you know that the atom is consist of, this is an atom, and inside it we have this positive charge nucleus with consists of neutron and proton. Okay, and around this nucleus we have an electrons, and this electrons move around it inside this sphere. So proton and neutron make up the nucleus, and electrons surround the nucleus. So electrons is move free around this nucleus, and it consists of neutron and proton. So it's make the mass of atom. So all the mass of atom is concentrated here inside the nucleus. So how then are atoms of hydrogen, for example, different from atoms of oxygen? So how we can say that the hydrogen and oxygen are a different atom? How we can answer? We talk about mass number and atomic number. So let's go to the second slide here. So what you can see here. So we say that the lowest number is the number of atomic number, is an atomic number. So this represents an atomic number, and here this is an atomic number. Okay, no matter what the location of this number, just the lowest number and the most lowest number here is an 1 and 8, so that is an atomic number. The largest one represent an atomic mass or mass number, and here we have a mass number. So we have a different atomic number and mass number for hydrogen and oxygen. So that means we have a different atom, right? So what make an atoms different? What make elements different from each other? Yes, true. The difference of atomic and mass number make elements different from each other. Elements are different because they contain different number of proton. If they have a different number of proton, that means we have a different atomic numbers. An element's atomic number is the number of proton in the nucleus of an atom of that element. So this is a number of proton. Atomic number is a number of proton inside an atom. So if we back here to hydrogen and oxygen, we say that hydrogen have 1 atomic number and oxygen have 8 atomic number. So that means oxygen have 8 protons and hydrogen have only just 1 proton. If we have just 1 proton here and we have an atomic weight with just 1, close to be 1, what's the number of a neutron? We will answer that in another slide, okay? So look here about carbon. This is simple represent carbon, and as you can see here, it's a neutral. We don't have any charge on it, and we say that the nucleus consists of neutron and proton, and this electron just move around this nucleus, and this is an atoms. Yeah. So what about the mass number? We say that the mass number in the first of this lesson, we say that the mass number is the number of proton with this charge and the number of a neutron, and it's a neutral. Okay, and this number of proton is the same number of atomic mass. So atomic mass and number of neutron represent the mass number. Why? Because the atomic mass represent a number of proton. So all of you know that the mass, okay, are concentrated inside the nucleus, which we can find the proton and neutron inside it. So the mass of atoms come from neutron and proton, and the electron is very, very small and have a very small mass. So we just have a mass of proton and neutron, and we neglect the mass of electrons. So the total number of proton and neutron is on the number of mass number, is the mass number, and we say that in the first section. Yes. So mass number, the mass number is the number of proton and number of neutron, and this can be represent a nucleus. Okay. So we have here a number of proton, and then we know that is an atomic number. And here we have a number of neutron and number of proton, and proton and neutron concentrated inside the center of atoms. That means it's make all the mass of atoms. That means it's an atomic mass. It's make all the mass of atoms. That can help you to remember the difference between it. Yeah. So let's back here. we have this sample here with different type of sample here. We have a hydrogen, and hydrogen have just a one proton and again one proton. So one proton and one electrons. So here we have a one proton represent a mass number and one proton represent a atomic number. So where's the number of neutron? The hydrogen atom just have one proton and one electron. Yeah, we have a different isotopes that have number of neutron, 1 or 2 number of neutron, but the hydrogen atom, we have here just have a one proton and one electron. This is a one atomic number and this is a one mass number. So we have a one mass number come from proton and one atomic number. So this come from one proton plus 0 neutron. We don't have any neutron to give us just a one mass number. And this is a type of element. So what about helium? The smallest number is an atomic number and the largest number is the mass number. So if I want to find the number of a neutron, we say that the mass number is an atomic number plus the number of neutron. So we take the mass number an atomic number plus number of neutron. Why? Because the atomic number represents the number of proton inside the atom. So what is the mass number for helium? It's 4. What about the atomic number of it? It's 2. And we want to find out the number of neutron. So the number of neutron is 2. Now let's go to lithium. We have a 7 and we have a 3. Which one represents a mass number and which one is an atomic number? The largest number is a mass number. So 7 is a mass number. And the smallest one is an atomic number. So what the number of neutron? This is an mass number and is equal to atomic number, which is 3, plus the number of a neutron. So the number of a neutron here will be 4. Let's try another example. We have PE, we have a 9 and 4. We have this large number, so it's a mass number. A smallest number, the small one, is an atomic number. So what is the number of neutron? We can say it's 9 minus 4. So 9 minus 4 is a 5. So the number of neutron here is 5. In the same way we have. So right, the rule here is percent A plus N is the same to P plus N. This represents the charge of proton and the neutron. Now what about this one? We have an 11 and 5. So the mass number is 11 and the atomic number is 5. So what is the number of neutron? Yes, 6. It's 6. It's back to the carbon. Have a 12 and 6. We have this two number. Which one is the most, which one is the large number? Yes, 12. So that means it's a large number, and 6 is a very small number. So the number of neutron is 12 minus 6 is 6 neutron. We talk about proton, neutron. What about the electron? So let's go here. Yes. So again, who can tell me which one of this number represent an atomic number and which one is a mass number? Again, the large number is a mass number and the smallest one is a atomic number. So this is a mass number and this is an atomic number. Okay, this is an atomic number. Okay, this is a mass number and this is an atomic number, and we have here, yes, we will talk about this unit later. Okay, it's called an atomic mass. Yes, so this is a sample of sodium elements. Okay, and this is a mass number and this is an atomic number. Okay, so if we want to know what the number of electron that sodium have, it's back here, and let's take another color here, different color. I will show a different color, just a minute. Yeah. Okay, we say that the mass number is an atomic number plus the number of a neutron. So we have 23, 11 plus number of neutron. So number of neutron is 23 minus 11. This will be 1, and 3 minus 2 is 12. We have a 12. Okay, 12 neutron. What about electron? Is this sodium have any charge in it, or just neutral? It's just a neutral. That means we have a 0 charge. So if any atoms have a 0 charge, that means the number of electron and number of proton is the same. Why? Because the positive and negative charge, if they have the same amount, that means the component is neutral. So if we have the same amount of proton and same amount of electron, that means we have a neutral atom. Okay, so here we have a 0 charge. That means we have a neutral atom. So that means the number of proton must be the same number of electrons. So what the number of proton? The number of proton is an atomic number, and the atomic number we have is 11. So we have an 11 number of electron and 11 number of proton. It's plus and this negative. Minus 11 plus 11 give you a 0 charge, and that's why the sodium atoms is neutral. So let's go to this example here. Yes, so look here, we have a 0 charge, right? And here we have a positive charge. So what that mean? If you have an atoms and this atom have become a positive charge, if the 0 charge become a positive charge on atoms, that means we decrease or increase the number of electrons. If the charge convert to be more positive, if 0 charge convert to be positive 1, if that means I decrease the number of electrons by 1 or I increase it by 1. How we can know that? So we say that if we have a negative charge, the number of negative charge and number of positive charge is the same, we will have a neutral compound or atoms. But if I have, this is the same, if I have a negative charge more than the positive charge, that means we will have a negative charge on atoms. If I have a positive charge more than negative charge, so that means the atoms will be positive. And here we have this state. So the sodium become more positive. So that means I have a more proton than electron. But what the number of proton and what the number of electron? So because that charge here increased just by 1, that means we have just one more proton than electron. Just we have one more proton than electron. That mean I remove one electron from sodium. I remove just, if I take this here, we have the result should be +1. So here we have a +1, and the number of proton always stay the same, not change. We cannot change the number of proton, so always be the same because it's localized inside the nucleus, so we cannot change it. So always the number of protons stay the same. So if we want to change, we just change. If we want to change number of any of this subparticle, we change just the number of electrons. So here we have a number of electrons and we don't know what is the number of electrons now. Okay, and this is represent the number of proton, and the total charge is 1. So if we decrease minus and minus, so remove this proton here, the number of electrons will be -10. So the number of electrons inside these atoms is 10. Why? Because we remove just one electron from sodium atoms, and that why the number of proton increase in this result, in this product. Okay, where's the mouse? Yes, yeah. So number of proton is 11, the number of neutron is 12, the number of electron is 10, and we say Y, and atomic number is 11, and mass number is 23. So let's try this example. So first thing, which one of these number is an atomic number and which one is a mass number? This is a large number, represent an mass number, and the smallest number is an atomic number. So if I want to find, this is a mass number, if I want to find the number of a neutron first, so what is the mass number is 24, and what is the atomic number is a 12, and what is the number of neutron? So in the result, the number of neutron will be 12. What about electron? How many electrons we have in magnesium? So if this atom here have a positive or negative charge, or just a neutral? Yes, just a neutral. So if we have a neutral, we say that the number of proton is the same number of electron. So these atoms have the same number of proton and electrons. So how many proton we have? The number of proton is an atomic number. It's a number of proton, and that means it's a number of electron. So number of electron will be 12. What about Cl? This large number is mass number, and the smallest one is atomic number. Okay, here again the mass number is equal to A plus N, and this is a number of proton and this number of neutron, and here we have a 5 plus number of neutron. So the number of neutron here will be minus 17. So 30 minus 20, yes, that will give you 18. Okay, number of neutron. Sorry about that. Okay, what about the number of electron? Where the mouse? Yes. So what about the number of electron? Here we want to find the number of electron. Okay, back here, it's back here, we have our neutral atoms. That means the number of proton and electron the same. So what we have here is just the number of electron is the same number of proton with positive charge, and is the same number of atomic number. So we have a 17. Yes, I just back here. Yeah, so we solve this. Okay, let's try the aluminum. What about the aluminum? This is an atomic, and this is an, yes, this is an atomic mass. Okay, it's okay, it's an atomic mass, the same as a mass number. And here we have an atomic number. Okay, atomic number. So atomic number here, we have a mass number, and this mass number, well, to atomic number, we solve for aluminum, okay, not for sodium. Okay, so how many number of neutron we have? What the number of neutron is? 26 0.9 minus 30. And that is the number of neutron. Okay, so what is the number of electron? Is this atom neutral or not? Yes, it have a zero charge. If it's have a zero charge, that means it's neutral. So because it's a neutral, so that means we have a 13 electrons. Okay, we have this example. Yeah, we solve for this. We determine the number of neutron. So the number of neutron is mass number minus the atomic number. Yeah, so it's 4 minus 2. So number of neutron is 2. We can determine it now. So what the number of electron? If it's neutral or not? Yes, it's neutral. So the number of electron is the number of proton. That means we have a 2 electron. What about hydrogen? If we go to hydrogen, the atomic number, we have this mass and mass number, and mass number is an atomic number plus the number of neutron. So what the number of neutron we have? This is 1 and this 1. So the number of neutron is 1 minus 1. So we have a 0. We don't have any neutron inside the hydrogen atoms, this type of hydrogen atom. Okay, if I want to know what the number of electron, if this hydrogen neutral or not, yes, so it have a 0 charge. So that means the electron and proton have the same number, and that means we have just 1 electron. So this hydrogen atom has 1 electron and 1 proton. Okay, we have a different example here. So this is a large number, and this example help you to practice. Okay, we have a large number and we have a small number. Small number is atomic number and large number is a mass number. Okay, a mass number or atomic mass. We should have a mass in it. Atomic mass or mass number, the same. Okay, same to solve the problems, not exactly the same. So exactly. Okay, so we have this mass minus the atomic number, give you the number of neutron. So try to solve it alone. Pause the video and try to solve this problem. So in the result, we will have this number of neutron. So what about the electron? What the number of electron we have? So number of electron is a neutral atoms. So that means I will have let's change this example. Why we don't say we have an Si plus 2. The number of proton increased by 2. If the number of proton increased by 2, what is the number of electron? So the first thing you can do is that we try to find the number of electron. So number of proton we have, and number of proton is not 0, is just plus 2. Okay, so the number of proton is 14 minus 14 and minus 14. So in the result, the number of electron is minus 12. So we have just a 12 electron and we have a 14 proton. So we decrease the number of electron by 2. So we remove 2 electron from atoms. Okay? Okay. So let's back to Ag, Mercury. So the largest number and the smallest number, it's very large. Okay, so we say that 200 is an mass number. If we decrease it by 80 is a number of, it's an atomic number. We'll have 120, and that is a number of neutron we have. So what the number of electron is, have a 0 charge. Is the number of electron the same number of proton? Yes, because it's neutral. What about Ge? So let's change the charge of it. Don't want this charge. Let's make it plus 4, for example. Again, what is the number of electron? First thing we do is take the number of electron and the number of proton and it's plus 4, right? So the lowest number of this 2 number is a number of proton, is an atomic number. So this is a large number, represent a mass number, so that is a number of proton. It's the lowest number here. Okay, we take it with the mouse. Yes, here we have an electron plus is 4. So what the number of electron we have is okay, so this is the number 28 is the number of electron we have inside this atoms. And if you want to find the number of neutron, it's the same way. The change in number of electron will not change the number of neutron, okay, or the mass number. Just change the charge of atoms, okay, just effect on the charge of atoms. So we can solve for the neutron in the same way. So the number of proton we have and the number of neutron. Again, the mass number is the number of proton and number of neutron, or it's an atomic number. Mass number, okay. Just back here. So number of neutron will be 7 minus 3 is 5. Sorry, it's 4. And 4 minus 2 is 2. So number of neutron is 42. Okay, we have an Fe and Fe plus 3. So let's try this example. We'll solve for Fe plus 3. Again, what is the number? What is an atomic number? Is the lowest number we have. We have a 26 number, and the large number we have is a mass number. So what the number of electron? So try to solve this problem alone, then back to this video. Now if we want to solve for electron plus proton is plus 3, that means number of electron plus atomic number, so number of proton is a 26. So what the number of electron we have? So the number of electron we have is 23 minus 23. So we remove 3 electrons from atoms. Look here, we added 1 electron to make it 10 electron, so we'll have a negative charge. That for F minus. So let's solve for F minus. It's the first negative charge we have in atoms, so we have a negative charge. So if we have a negative charge, that means the number of proton more than number of electron, or the number of electron is more than the number of proton. Yes, the number of electron is more than the number of proton. Why? Because we have this negative charge. Okay. Now we try to solve for F minus. Just let's clean everything here. Yes. So say that the number of electron is more than the number of proton. We will use the same way to solve for the number of electron. So the number of electron plus the number of proton is 9, is minus 1, sorry. So what the number of proton? From this picture you can know it's 9. So electron plus 9 is minus 1. So minus 9 and minus 9, the number of electron will be minus 1 minus 9, and that give you a minus 10. So the number of electron will increase by 1 to be minus 10, and you can see that here. Okay, so we have a calcium plus 2 here, and you have a Cu and Te. I will solve all this problem to help you to understand. Okay, so don't worry. I don't like this color. Let's try this color. Okay, let's try this type of color. Yes. Okay, we have a Cu. So let's take this Cu. I will let's see if we have a plus 1. So what the number of electron? The number of electron is electron plus proton will give you a plus 1. Okay, this is a total charge we have. So the number of electron, we need it, and the number of proton here is this is a small number and this is a large number, so we take the small number as a number of proton. So 26 to give you a plus 1. So in the end, the number of electron we have, try to find the number of neutron alone. Okay, so we have a minus 25. Okay, this is a minus. The number of electron is minus 25. Okay, let's go to this atoms. We have this atom. Okay, and see it's have a plus 5. Okay, so what is the number of electron? The number of electron we have is, we can find it in the same way. The electron plus proton will give you plus 5 total charge, and these electrons, we need it, we try to find it, and the number of proton we have is the small number. So which one of these numbers is the most small? The smallest number is a 52. So the result is plus 5. So the number of electron is 5 minus 52, and that will give you minus 447. That is the number of electron. Try to find the number of neutron alone. Okay, let's solve this calcium. What do you think? The number of electron increase or decrease? Is the number of electron decrease or increase? We remove electron or we added electron to atoms. So if the number of proton increase, that means we remove electron. So what the number of electron we remove? How many electron we remove from these atoms? If we have a plus 2, that means This is a total number. So we have this equation again. Electron plus proton will give you a +2 charge for atoms. Okay, so the number of electrons is a number of proton minus the number of proton plus 2. Okay, so we can write it like this. So the number of electron is less than proton 2 minus b. That means the number of electron here is less than number of proton by 2. Why? Because any number we added here for proton will be less than the electron by 2. Okay, the electron will be less than it by 2. So if we have, if the number of proton, for example, if the number of proton is 6, the number of electron will be 2 minus 6, so it will be decreased by 2, and here it's decreased by 2. So can you understand that? So that means that we decrease the number of electron for this calcium atoms by 2. So any type of proton here, any number of proton, okay, the electron will be decreased comparing with it by 2. Okay, so the difference between electron and proton is 2. Why? Because we have this charge here, the stiff charge. Okay, let's go to, yeah, this is another example. You can see we have a different proton. This is a proton. This represents an atomic number, and this represents a mass number. This is a mass number, this atomic number, this mass number, this atomic number. Why? Because this is a large number and this is a small number. Okay, and here, can you see here we have a two different number? It's close to each other, but they still different. We can talk about that in a second lecture. Okay, so we finish here today. Okay, so good.